In this video, you'll learn how to create and use conjoint experiments in SightX. Conjoint analysis is a form of statistical analysis used to determine how customers value different aspects of a product. In a conjoint experiment, respondents are shown combinations of potential products. For each combination, they select the products that they would most likely purchase. SightX then evaluates the products that respondents chose versus the products that weren't chosen to build an analysis based on the importance of the characteristics that make up a product. For example, let's say we're a soft drink company considering adding a lime soda to our product offerings. We want to evaluate how the new flavor would impact sales of our current product portfolio and how it would perform against the lime sodas our competitors have on the market. The in-survey experiment shown to respondents could look something like this. To run a conjoint experiment, start from the Create page of a project. Choose Conjoint in the Methodology section of the Add Item menu on the Create page. In the initial experiment setup, first give your experiment a title. The title won't show in the survey, it's just used for a reference in the case that you have more than one conjoint in your project. Next, write the introductory description of the experiment that will be shown to respondents in the survey before the conjoint questions begin. Finally, write the prompt that will be shown with each set of choices. It's important to specify that respondents should choose their most preferred option. Next, you'll input your product variations and configure any restrictions you might have. In a conjoint experiment, your product or service should be broken down into attributes. An attribute is a specific characteristic of your product. Using our soft drink example, our attributes could be brand, flavor, price, and volume. The attributes you choose should be the characteristics that vary across your product portfolio and those of your competitors. Let's start with our flavor attribute. In SightX, there are three types of attributes: categorical, numeric, and prices. Categorical variables are things like flavor, brand, and color. Numeric variables are things like volume, length, pounds, anything with a numeric measure in units other than price. Price attributes are just that, attributes for the cost of the product. It's important to differentiate between numeric and price attributes because only price attributes can be used to calculate elasticity and expected revenue. Our flavor attribute is categorical. So next, we'll define the individual levels within the attribute. Levels are the potential options an attribute can have. So for our flavor attribute, we'll use the levels lime, cola, orange, and ginger ale. Lime is included as the potential new flavor we're testing, and we've included the other flavors of soda we currently sell to determine the share of sales the flavors would have if we. The next attribute we're going to add is volume, because bottles of soda can have different sizes. Volume is measured in liters, so it is a numeric variable. Our brand only sells 0.5 liter bottles, but our competitors sell lime sodas in 0.75 and 1 liter sizes. Since we want to see the market share our lime soda would have amongst our competitors, we'll include the sizes they sell as well. We'll also specify that our units are liters so that our respondents have context for the sizes. The next attribute we'll add is price. Testing a price in your conjoint allows you to use the experiment to measure the demand for your product and to understand which product characteristics consumers are willing to pay more for. We'll select our currency as US dollar and enter the prices we could reasonably sell our product for and our competitors' prices. Here, we'll also specify that the attribute is ordered, meaning that some levels are more attractive to consumers than others. Price is a good example of an ordered attribute because in almost all cases, lower prices are preferred by consumers. when ordered is turned on, we need to make sure our levels are arranged from worst to best as indicated by the scale on the right. So far, we've added our attributes in a way where any combination of flavors, sizes, and prices can be shown to respondents. However, there may be certain products that don't or can't exist and shouldn't be tested with respondents. The best way to handle this situation is adding a conditional attribute, which is an attribute whose levels depend on the levels of another attribute. For example, we might have a scenario that higher volumes of soft drinks cost more to purchase, so higher volumes should not be paired with lower prices. To do this, we're actually going to create a new price attribute as a conditional attribute. First, we'll select the independent attribute, which is the attribute whose values will define which level of the conditional price variable will be shown. In this case, the independent attribute would be volume, since the volume of the product determines the possible prices. Once we do that, a table will appear with the levels of our independent variable so that we can define the levels and values for our conditional variable. Now we'll define the levels for our price variable. For every size soft drink, we want to test a low, a medium, and a high price, where the actual prices shown for each size will differ based on that size. Now we'll input the high, medium, and low possible prices for each volume. This way, we can ensure that the products presented in our test reflect the actual products that we or our competitors could theoretically sell. We can now delete the former price attribute that we created since we need to use conditional prices instead. Now that we've configured all of the attributes and levels that we want to test, we could be finished defining the experiment. However, we're going to take a quick look at the advanced configuration options available. We may want to allow respondents to answer that they wouldn't prefer any of the products shown in a given set by providing them with an opt-out option. It can be beneficial to allow this so you're not forcing respondents to choose a product when they dislike all of the products displayed. However, respondents who become fatigued during the experiment may overuse this opt-out option. Next, let's look at pairs to exclude, which you can use to prevent certain pairs of levels from appearing in products together. For example, maybe we don't have an orange soda currently in our product line of our 0.5 liter bottles. To create the exclusion, we'll select flavor and volume attributes and select the pairs that we want to prevent from occurring in the test. You can also define full products that shouldn't be shown in the experiment under products to exclude. For example, let's say lime flavoring is expensive, so lime soda is never sold at the highest volume and the lowest price. Here, we can add that product to specify that it should definitely not be shown to respondents. Finally, it's also possible to define products that must be included in the test. For example, we could specify that our new lime flavor we're considering must be shown with the 0.5 volume and the high price at least once to each respondent. We advise that you only use these advanced options if absolutely necessary, as they can cause levels to be shown an unequal number of times. This can cause results to be biased towards the levels that are shown more frequently. Now that we've defined all of the product inputs for the experiment, it's time for SightX to actually create the product combinations that will be tested with respondents. Click on Generate Products and then Proceed to confirm you're completely done with the attribute definitions. The process is complex and can take several minutes, so feel free to continue building your survey while the experiment is being generated. SightX will notify you when it's ready. Now that our products are ready, we need to specify how many products we want to show per choice set in the survey. Respondents typically have an easier time when there are fewer products to choose from at one time. But showing fewer choices requires showing more combination sets to each respondent to collect the data that you need, and showing too many sets can fatigue respondents. Consider how long the rest of your survey is, how engaged or interested your respondents will be in these types of products, and how different your variable levels are. Now click Finish to instruct SightX to create the choice sets, the final step in generating the experiment. After you finish creating and testing your survey, you'll distribute it to respondents to participate in the experiment. In the next section of this video, we'll review the results of our experiment and see how we can use them to make decisions around our new lime soda product launch. Once you've finished collecting responses to your survey, you're ready to view the results of your Conjoint experiment. First, we'll review the basic results of the experiment, which levels are most preferred, and which attributes are most important to customers. After that, we'll dive into our Conjoint simulator, where we can identify optimal products and their target markets, view market share, and calculate demand curves and product elasticity. To begin reviewing Conjoint results, navigate to the Question Analysis tab in the Analyze section of the project. The first thing you'll need to do is calculate the experiment results. The calculations are complex and can take several minutes to run, so it's best to only initiate the calculation when you've completed response collection. SightX will notify you when your Conjoint results are ready. The first output we'll look at is the level performance graph. This shows how much influence each level has on respondents when they make decisions, and whether that influence is positive or negative. Levels with higher absolute values, distances from 0, are the most influential in decision making, while those with values closer to 0 don't have as much influence. Here, we can see that the flavors cola and ginger ale are drivers of product selection, with cola being the flavor that most influences customers to choose a product. The other two flavors, lime and orange, are more influential in customers not choosing a product. The various soda sizes all have performance scores close to 0, meaning that they were not very influential in respondents' choices. However, here we can see that the levels that were most influential overall were the low and the high prices, with the low price being the most positively influential characteristic and the high price being the most negatively influential. Next, we'll look at the overall attribute importance, where we can see how influential each attribute is in customers' decisions. We can see that consumers are influenced the most by the flavor and the price of our proposed sodas, while volume did not factor very much into their choices. The level performance and attribute importance give you an overall idea of consumer preferences, but they only show a fraction of the insights that you can get out of a Conjoint experiment. To enable you to fully take advantage of your Conjoint experiment, SightX offers a simulator for you to get the most out of your data. Click the Go to Simulator button, or click on Simulators in the left side menu and select Conjoint. In our Conjoint simulator, you have access to two powerful tools, the segmentation tool and the demand simulator tool. First, let's take a look at segmentation. By default, SightX creates a segmentation that includes all of the respondents in your study. You can create additional segmentations using a filtered set of respondents, but for now we'll review the default segmentation for all respondents. In the segmentation, you'll see your population divided into groups called segments that are clustered around their predicted preference for a potential product. These segments can be used to find product combinations to produce and to determine the target market for various products and levels. The more segments you divide your population into, the more reliable the predicted preferences of each segment are. However, having many target consumer groups typically involves a lot of overlap in the preferred levels of each group and can make it difficult to determine the meaningful differences in your segments. By default, SightX indicates an optimal number of segments, which is the fewest number of segments that still meet our required level of confidence in the accuracy of the preference predictions. In our experiment, the optimal segmentation is two groups, one comprising around 80% of our population who prefer the cola flavor, the 1 liter volume, and the low price point, and the other segment comprising around 19% of our population who prefer the lime flavor, the 0.75 liter volume, and the low price point. Below these segments, we can view the level performance and attribute importance for each individual segment. Based on our analysis and segmentation so far, we can see that we have two distinct groups of consumers, those who prefer the cola flavor and those who prefer lime. While their volume preferences differ, we know that the volume attribute is not very influential in their soda purchases in general, so we can choose to focus on the flavor as the differentiating factor. Once you know which products and levels you want to focus on, your next question will probably be, who are the people who make up each segment? Knowing the demographic skew of each group allows you to understand the target market of each product of interest. To learn more about the people who make up a segment, click the magnifying glass on the segment card. However, the easiest way to spot differences in the demographic makeup of each segment is to compare the responses of all the segments at the same time. You can do this by clicking View Segments. Here we can see one data series for segment 1 and one for segment 2 across all of the questions in our survey. We can see some skew for males towards segment 2, the group who prefers lime, and for non-binary folks towards segment 1 who prefer cola. But scrolling down to the age demographic shows an even clearer skew. Segment 1, cola, are all on the younger side, while segment 2, lime preferers, are all above age 41. This clear data on the differences in who makes up your segments allows you to make better decisions about marketing resources, as well as understand portfolio cannibalization as you consider which products to launch. Navigating back to the Conjoint simulator dashboard, let's review how to use the demand tool to examine individual products and product portfolios to determine market share and elasticity. Each demand simulator you create revolves around a specific set of products, so you'll first need to define the products you're interested in analyzing together. These will differ based on your goals. You may want to see how a potential new product would impact sales of your existing product portfolio, or you may want to see how it would fit in the market with your competitors. Let's say we want to see how our lime soda would compete against our competitors. To do this, we'll create our competitors' lime sodas, as well as the lime soda we are interested in developing. When we click Calculate Demand, the market share will be calculated for the products when consumers are presented with a choice between these specific products. Here, we can see that our new lime soda will capture almost 50% of the market at the 0.5 volume and medium price. We can adjust the levels of our product to see how product variations perform on the market. For example, we could change the price of our product from the medium price to the low price. Now we can see that undercutting our competitors with the lower price would bring our market share up to around 80%. If we want to change the product set entirely, say to test our lime soda against our other existing flavors, we could instead create a new demand simulation from the simulator dashboard so that we don't lose this demand simulation with the products that we've already created here. If you have a price attribute included in your experiment, you can also analyze the demand for products at different prices and calculate elasticity and expected revenue. Here, we can see the demand curve for each product when it is competing with only the other products in the simulation set. When we view our product, we can see the demand curve and how market share decreases as price increases. We can also see the demand elasticity over a specified range of prices. For example, we may have decided that we want to price our product between 50 cents and 60 cents. When we specify that price range, we find that price elasticity is 1.9, and our product is elastic within that range. Price elasticities greater than 1 indicate that changes in price within the range will have a significant impact on demand, while elasticities less than 1 indicate that changes in price won't have a significant impact on demand. The higher the elasticity is, the greater the change in demand will be. If we scroll down, we can also simulate our expected revenue. By entering the expected number of consumers in the market and considering the revenue maximizing price shown, we can see the total expected revenue of this product, considering a market where the only products available are the ones we've created in this simulation.